mostly. Okay, hi everyone. Welcome to the session. Okay, my name is Peter Glendon. Before I start, let me give a little short intro about the company and myself. So if this is not your first WA2, you will see the same slides over, not your first revision with us. You'll be new to you. If you have joined us before, then I beg your pardon. Let me just do a bit of self-sharing again. Okay. So, hi, welcome to OVERMUGGED. This is our revision program for WA Online, okay, for pure bio as well as online bio as IP bio as well. Okay, basically, this whole topic is for the bio kids who are going to sit for WA for these three topics. Now, these are our centers. We currently have about 1,000 students. Okay, I think about 1,002. Right now, I'm inside the Kovan outlet and it's raining very heavily outside, but it's quite nice because the windows are very big. We have an outlet at Tampines, Marine Parade, Toa Payoh, Bukit Timah, Bishan outlets. Okay, let's check. Right. Yes. Then generally we do pretty decently with our students. So about 7 out of 10 kids achieve distinction in the national exams. Okay, I think nothing new to you guys. And yeah, we generally have very experienced teachers. I'm formerly from MOE. I have colleagues from Learning Lab. Okay, and generally we are experienced bunch of teachers who are here to try and help you learn best as you can. And hopefully through the WA sessions online, you will see, yeah, the teachers really do deliver on that. Okay. So yeah, this is me. I'm Peter Glendon. I teach A-level, O-level, IP bio. So right before this lesson, I was having a GC2 bio class. And before that lesson, I have my regular Sec 3 bio class. All right, so I'm formerly from MOE. I've taught many students for the last 10 years. Fun facts about me, I like this lady, and I like this lady. The one on the left, Bei Suzy. The one on the right, IU. Why do I bring about these two ladies? It's because I use them to teach the topic of respiration in junior college. So I say again, I use K-pop stars to help my GC2 students learn about respiration. And that's really the most important part about me. I like to use jokes and funny stuff to teach bio. Because bio after a while gets a bit dry. So most important is the teacher can connect and tell you funny stuff to help you learn. Now, more fun facts about me. I love to cook. That's me, something I cooked during COVID-19. As a young boy. In all honesty, this part is just for me to showcase my cute little boy. He's much bigger now. He's about 10 months. Also a former Team Singapore athlete. So the jacket you're seeing me wear now was on the 2019 SEA Games. So if you play floorball, let's have a chit chat, okay, about how the sport is like for you. Then another fun fact, my wife and I appeared in a Lego advertisement before. So we were advertising for Lego about this particular place set at the Marina Bay Sands area. And it was basically showing my love story to the whole world. You can still try and find it on YouTube. Not easy to find, but it's there. Okay. Now, how come you should be assured that whatever I'm saying can be trusted? I did a degree in bio, okay, at NTU. Then I went to teaching on a teaching scholarship. Then at graduation ceremony, I got a chance to give a very nice speech. So it's very, very fun. After that, I went to TJC. So that's me teaching in school in a strawberry outfit. So that's how wacky and fun I can be in class. And same thing applies here at the tuition center. And I left to go to another ministry to do some work. Okay, went to another company to train other country civil servants. But eventually I returned back to teaching because I really miss the interactions with the students. Right. So here's my teaching philosophy. Once again, it's another chance for me to show off my cute little boy. But basically, I believe teaching is a performance, right? Boring, slow, dull lessons nowadays cannot handle it. Okay, no one got time for that. And if I can use education, if I can teach you with humor, why not, man? I try to choose funny stuff to help you learn better. And I think most importantly, by the time you come to me for tuition, or you come to me for this WA online part, you need help with certain things. I should make it easier for you to understand. Okay, not make it more complex. All right, okay, so I'll come to this later. Now, I will go to the next part, okay, for the main part of why you're here today, which is the lesson proper. Now, so just to be clear, how the whole lesson will be like today, it's only 1.5 hours. I will spend about 10 to 15 minutes per topic to touch on the part which I think most of you would need a bit of help with, either remembering or in terms of understanding conceptually. Then I'll go straight to the paper. Right, because I think the paper is where I can give you the most value add in how you should approach doing questions. Right, but in the meantime, Any point of time, if you feel you have any questions, okay, you want to ask about certain part, please either unmute yourself to share, or if not, you can just drop me a text in the Zoom chat. Okay. Now, if not, let's go. All right. Now, biomolecules, okay, enzymes. All right. So first thing first. Okay. So for this topic of carbohydrates, okay, they generally want you to see the world into 3 different categories. 1, 2, and many. Okay, 1, 2, and many. The trick here is this. For function-wise, 1 and 2 is mainly for energy and food. Okay. For the many, it's going to be storage as well as support. So it will help you greatly if you can see these whole 3 parts into 2 clear categories. One is simply energy and food. The other one is for storage and support. Okay, next, right? So the first thing you have to know about the 3 different biomolecules is they like to compare the element composition. So I will draw your attention to 2 things. Stay on this page, okay? But firstly, for carbohydrates, the key thing here is CHO. But what is the difference between the other biomolecule that is full of C, H, and O only? This one has a fixed ratio. When I zoom down really quickly, okay, right, over here, to my triglycerides, this one also C, H, and O. But there's no fixed ratio. So there is no 2:1. Then, when I zoom down into my proteins over here, you will notice C, H, O, and an N. So when I go back straight to the top, how should you approach the revision for this part over here? They will test you the element composition, usually in MCQs, or a 1-mark structured question. And what would they do in the MCQ? They might give you 4 different options with varying chemical composition. It can be a C16, H54, O2, or it can be a C6H12O6, or it can be a C19H42O30 N4. So there are 3 main categories of options that they can give you. Sorry, yeah. 3 main categories. What you need to be sharp to realize is this. First one, if I see my oxygen and hydrogen, the number nowhere near the 2:1 ratio, this is a lipid. Okay. Next, if I see my hydrogen and oxygen, there's a 2:1 ratio, it's a sugar. Okay. So you need to be able to see the clear difference. This is a ridiculous number of hydrogen. And it will always be the case because when it comes to your lipids, there is truly so much more hydrogen compared to oxygen. Then for protein, very easy. Okay, for protein, very easy. Why? Protein, once I see there's a nitrogen there, straight away, protein. I don't even bother counting. So what's the trick here once again? Nitrogen, protein. Fixed ratio of H2O, sugar. Ridiculous amount of hydrogen and very little oxygen, lipids. Right? And that's how you do the element composition as you revise it. Right. Then, okay, role of glucose, I won't go through, you all know lah. It's simply just for respiration. Okay. The substrate for lipid and amino acid synthesis, yeah, this is a function, but this is the main one they love to test you in school. So once you think of glucose, I think of cellular respiration. All right. Then now, this is the part where sometimes you will struggle to remember. Okay, because in the exam, they will give you, I give you a lactose. What makes up lactose? Same thing for sucrose and maltose. Now, the way to remember this is my approach. If you join my class, my wallpaper is usually my wedding photo. So it's a photo of me and my wife. Okay. Every time people say, "Wow, Mr. Phua, your wife is very pretty." Of course, I agree. She's very pretty. That's why I married her, among other things. But then always wait for the next part. Like, yes, she's pretty and the groom is no one ever says the groom is handsome. I'm so sad. But that's not the point. Key thing is, I believe in my marriage and I believe in using it to help you remember this table. So if I'm thinking, marriage and this, let me prove it to you. So first thing first, there are a lot of weddings in the world. Weddings go by sizes. So what are the sizes? Small, medium, large. So small, medium, large, that is your sucrose, maltose, lactose. Okay, so small, medium, large. Then it's my job to help you remember for each of the disaccharides, what makes up the disaccharide. So first one, okay, once again, it's the marriage, right? Before I can get married, what is step number one? Step number one, I must find a girlfriend. Which kind of girlfriend I want to find? I want to find a sweet one. So sucrose is glucose plus fructose. What is the abbreviation here? It will be sweet girl friend. Now, if you are a girl, then obviously you will date the boy, you'll be a sweet guy friend, also can. So sucrose, sweet girlfriend. Then now, I found a girlfriend. In order to get married, what is the next step? The next step would be to find, after finding a girl, I want to get married. So if I want to get married, the next step would be, I marry the good girl. So both is G, right? So marry a good girl, glucose plus glucose. Okay. Then last part of the story, after you have married a good girl, it doesn't end there. Marriage is for life. So you must love the good girl or slash guy. So lactose, what makes up lactose? It will be made up of glucose and lactose. So this is one way you can remember it, the story of marriage. Sweet girlfriend, you marry the good girl, you love the good girl or the good guy for the rest of your life. That is one way. Now, if some of you don't sort of cheesy, lovey stuff, don't worry, there's another way. If you don't want the cheesy stuff, then I go by patterns. What's the pattern here? So you realize in your monosaccharide, what do you have? My monosaccharide, I only have these three combinations: glucose, galactose, fructose. Three possible things you can choose from. So simply, first column of any of the disaccharide, they are all glucose. So just remember, every disaccharide got glucose. Then I'm just changing the third option. So the third option, okay, I'll start the easiest one. The reason why lactose is called lactose is because it has pure lactose. So galactose and lactose. Okay. Then sucrose. All right. Sucrose is found usually in fruits. So fruits for fructose. So sweet girlfriend, fructose is here. Then maltose is the only one left because you only have three monosaccharides. If I only have galactose and fructose out, I'm just left with glucose. Okay. Now, that's for this part. Now, when it comes to your reducing sugar test, okay, some ways they will test you. I just need you to know sucrose. Whenever you see sucrose, straight away non-reducing sugar. Everything else is a reducing sugar. So instead of you trying to remember this, just remember the one that is not. Okay, the one that is not. Now, here's the trick with food tests. So for all food tests, okay, I will leave it to you to again remember, okay, your school's version. But one thing to highlight to you is this. In my food test, whether it's a Benedict test, I will add 2 cm cube of reagent to 2 cm cube of a sample. Now, this same rule will apply to all your other food tests, okay? Except starch, starch or no, just put the thing, okay? Fats, same thing. Notice here, 2 cm cube of reagent to 2 cm cube of sample. When we come to our protein test, our Benedict test, same thing. Our burette test is the exact same thing. 2 cm cube of reagent to 2 cm cube of sample. So instead of remembering 3 different processes for your code test, don't do that. Just remember this rule. 2 cm cube for everything. I choose the reagent that I need for the test, and I just add 2 cm cube of whatever sample you are being tasked to test. Then that will make your code test easier for you to recall. Clear so far? Okay, and just to be clear, you can use the word burette solution as well as Benedict solution. But if your school teacher say you must write the full reagent name, then you follow your school. Okay. Now, that is for carbohydrates. Okay. Now, I will go to your triglycerides. Triglycerides. Okay, sorry. Carbohydrate. One last thing. Okay. Now, you just need to know which one is animal, which one is plants. This is plants. This is plants. And further, I said before the start, right? Okay, this whole thing here is about storage and support. So, my animals don't need storage. No, don't need support. My plants do. So this is only for plants, my cell wall. But for storage of energy, starch and glycogen are the same, but different. This is found in my plants, this is found in my animals. That's all. Okay, so just to be clear, humans do not store starch. We store glycogen, same as animals. All right. Okay. Now, for your glycogen over here, okay. Now, raw organism, long-term energy storage, okay. Installation below the skin surface. How do you remember all of this? I'm going to tell you this very incredible story, okay. Especially for the cushioning and the protecting of internal organs. I once saw this video online. Okay, it was this really very obese person. Okay, not judging the person, but this person was very obese, weighed about 250 kg. So bedridden. One day at home, this person heard the house being broken into. So a robber came in, the person heard a gunshot bang. And this person was like, hey, I heard a gunshot, but how come I don't feel myself getting hurt? Because usually gunshot, human, next thing you know is blood flows out, right? So this person was like, hey, I don't feel any pain, I don't feel any bleeding. A few months later, this person eventually went to the hospital for a checkup. And during the x-ray itself, wow, they realized there was a bullet stuck in the fats. And because there was such a thick fat layer, the bullet protected the organs from being damaged. So that's how you will remember, wow, the fats really cushion and protect the internal organs from impact. Okay, long-term energy storage. Everyone look at your father, mother, or older people. Generally, we have a belly. That's our fat storage. Insulation, it keeps you warm. Okay, then fourth one, your cell surface membrane. So quite straightforward to remember. Okay, now when it comes to your proteins, okay, I just need you to know, okay, how do you remember if you were to draw an amino acid, how to draw it? It's called amino acid for a reason. Amino on the left, okay, this acid part on the right. That's why it's called an amino acid. Okay, now what holds them together, okay, is a peptide bond, but eventually when it comes together, I get a polypeptide chain. So one thing I'll emphasize for this part of proteins is, you might be wondering, when do I use amino acid? When do I use polypeptide? When do I use proteins? This one is at the very beginning, when it's individual. So individually, they are called amino acids. When I join them to become this very nice long chain, okay, like your friendship band got a lot of beads, that is when I use polypeptides. Now, at the polypeptide stage, it hasn't been fully folded yet. So when it has folded nice, like you know how you wrap a gift? When you're wrapping your gift box halfway, wrapping paper, that in-between process, the wrapping paper is not fully folded. At the last part, after you fold, it will become that nice gift box all wrapped up. That principle applies to when my polypeptide is fully folded, it becomes a protein. So here is at the very end. Amino acids at the very beginning. This is the very end. You can see your polypeptides are somewhat in the middle of the whole journey. Okay. All right. Now, Okay, good in time. Moving on to enzymes. So for enzymes, okay, I will skip quite a bit because it's quite straightforward. But I will nag on some few things. First thing first, if the exam question, the W can ask you, using the lock and key hypothesis, explain blah, blah, blah. This is a common mistake students do. They like to start writing the answer. Oh, this is the substrate fits into the enzyme, blah, blah, blah. And when they write the answer finish already, right? You read back, the teacher will see, there is no mentioning of what is the lock and what is the key. But because the question says using lock and key hypothesis, your teacher can't give you full credit. So this is my tip for enzymes for this part. If the question is lock and key hypothesis, first line you write, okay, what is the lock? So I will say in the question context, let's say they give me amylase. Amylase is the lock. Then what is the substrate? Starch. Starch is the key. Okay, I will outright say in the first line, right? So that I guarantee that I fulfilled this requirement. Of course, what most students do is they try and weave it into the answer. Okay, worst case scenario is not there. Set case scenario. They mention amylase is the lock. Then halfway in the story, they never mention starch is the key. Okay. Then next thing to help you with is some kids get very confused. Sure, which one is the lock, which one is the key? I find it a bit hard. There are two ways you can help you remember. First one, go by size. The lock is always bigger than the key. Okay, so your enzyme is usually bigger than the substrate with on. Usually. So that's one, you go by size. Okay, then another way is to go by shape. You insert the key into the lock, or you put the lock over the key. Most people will say, I insert the key into the lock, right? So same thing, my substrate goes into my enzyme. So the thing that is going in will be the smaller key. The object that has the larger hole will be the lock of the enzyme. Okay, so either you go by size, okay, or you go by what enters and what receives. Okay, so far? Now, so in the whole process over here, what I want to nag on is this thing. When my enzyme binds to the substrate, use the word enzyme substrate complex. Okay, enzyme substrate complex. Now, this is the main type of questions they will ask you when it comes to enzymes. When it comes to temperature change, here is the trick. Okay, you need to know whether you are looking at a graph of temperature change or a graph for pH change. And how do you know that? First thing first, we look at where my optimal temperature or optimal pH is. From the early part of a low temperature to my optimal temperature, okay, will there be any change? Yes. The only change is just kinetic energy going up. So that's my first tip when it comes to enzyme and temperature. As long as the question tells you there's an increase in energy, you write this line. There is an increase in kinetic energy. So once an increase in kinetic energy, what happens now? This goes back to your step 2 science. Increase in kinetic energy. Your molecules will move faster, right? When they move faster, what happens now? My substrate and my enzyme can move faster. And they can move faster, higher chance they will collide, will have effective collision. That's why over here, okay, we say as temperature increases, reacting molecules have more kinetic energy and move faster. And then frequency of effective collision increases, forming more ES complexes, greater rate of reaction. Easy peasy. So if you never knew how to structure this way of answering or describing a temperature increase for enzyme, good for you. We have given you the answer below. Okay, so please use it. Then, when they reach this stage, optimal temperature, they are the most active. Now, that is why the graph will increase sharply. After optimal, you know will denature. Denature means what? This graph will straight away, it will market failure. Okay? It's like the current stocks. Okay? Last week, you don't know why your parents on Monday was angry for no reason, was because stock market crashed. So after optimal temperature, boom, it just crashes downwards. So you will see the temperature graph. One side crashes, one side slowly increases. So it's asymmetric. Okay, it's asymmetric. And beyond 40 degrees, what's the issue? It's just simply the enzymes have denatured because, once again, I start with kinetic energy. Increase in temperature beyond optimal, I increase kinetic energy, I break the bonds holding the enzymes, shape of active site is damaged, enzyme no longer complementary, therefore it's denatured. All right? So quite straightforward when it comes to enzymes. Just want to make a view to see the graph is asymmetric. Now for pH, why is it symmetric? Why? It is symmetric because generally anything the left or to the right of my optimal is denaturation. So if I'm denaturing, now when it comes to pH, it's a bit different from temperature. Why? At low temperature, I don't get any bonds breaking. Okay, so at low temperatures, there is no denaturation, just inactivation. But at pH, as I deviate further from optimal, there will be bond breaking. And that's why in our description, okay, it is the same. Above or below your pH, optimal pH, is the same thing. Deviations from optimal pH will break my bond, holding the three-dimensional structure of the enzyme. Then I zoom in on the most important part of the enzyme for its function. Specific shape of the active site is damaged. So put a star here, shape, and go back up for temperature, shape, okay. Why? Because shape is what should accompany your active site. Most kids are just right, active site has changed. Which part of it has changed? Flavor, color, smell, put the word shape. So if you find yourself always losing marks for this part you describe, how come I put active site change, my teacher don't give me full credit? It's because your teacher expects you to write the word shape. Shape of active site is damaged and therefore no longer complementary. Okay, so since pH is the same way, either left or right, increase or decrease, it's the same damage, same bond breaking, same denaturation. It's the same answer lah. So you have to remember two different sets of answers. Clear so far? Okay. So that's all for the very quick revision for biomolecules and enzymes. Now back to the part that I'm looking forward to doing the most, which is going through the questions. So if I do finish the questions early, all right, we will go back to the recap of the topic and I'll go to certain areas which I didn't touch previously. Okay, but if not, let's jump into the question. So question number one. Okay, question number one. How I go about doing this is I won't just straight away show you the answer. I want you to follow the way I analyze the question, because that is really what I think you are here for. So first one, it's a food test question. So what I have to do at the site is, instead of just looking at it, I will annotate and analyze. Then you're thinking, I also know what's the value add. So when I say annotate and analyze, I want you to write down what is the conclusion. So if I have an iodine test and it appears brown after the test, this tells me what? There is no starch. So I'll write down here no starch because why? Brown is a negative result. Okay, then Burette test, it turns purple. Purple means there is protein present. I know protein present. Emulsion test, what is this test for? Fats. If it's clear, means no fats. Then Bennett's test, what does this test for? Reducing sugar. So if it's green, how? Green, how? Okay, as long as it's not blue, means there's reducing sugar. And just to share a bit of information to you all, usually when the Bennett's test is positive, at the level of Sec 3, you can more or less expect it to be that is glucose. Okay? Because that's the most common reducing sugar you find. So glucose present. And then with that, very straightforward. I don't even need to look at the question now because simply I've done all the analysis here. For protein, got glucose. So what does the sample contain? Protein and glucose. Answer over here is A. Now, what I'd like to challenge my students to do is this. why are the other three answers wrong? So when you're practicing now, not in the WA, you got a lot of time, always do this trick, which is ask yourself, why are the other three answers you think is wrong? Why? So that later if I go through a question and you find out, hey, I'm wrong. Let's say, for example, I say, oh, this is correct because burette test is for sucrose. For example, hypothetical. Then I go through, answer one is correct. Two is wrong. Oh no, why? Oh, my understanding is wrong. Burette test is not for sucrose. Then you go back to your notes, put a note there. The last time I studied burette test, I was confused. So that every time when you make a mistake, okay, you know what is wrong. Then you get very good feedback on what you were wrong at, you can get corrected. But if, for example, now I don't like this, and you chose option 2, then you're like, wrong. Why? Why is that wrong? Yeah, I don't know. You can never learn from it. Okay, so let's get to that. This one, why can't it be glucose and sucrose? If I want to show the presence of sucrose, what do I need? I need a non-reducing sugar test. But I don't have it here. So that's why wrong. Then why cannot be starch and protein? Starch is not found here at all because I have a negative iodine test. Okay. Sesame oil, all the more cannot because emulsion test for fats is clear. So that's why the answer here is just A. A or 1. Right, question 2. This one. Okay. Shows the features of carbohydrates, fats, and proteins. So, what are some key things I can do? So for such questions, here's the trick. I don't find the right answer. No, I find the 3 wrong ones. They're like, isn't that more time consuming? No. It's very easy to find the 3 wrong ones. Why? As long as I can find something wrong in all of these options, I should already cancel. And it's easy to find the mistake because the mistakes are, the teacher usually when they set a question, they will make the mistakes pretty easy to spot as actually. So for example, first one, carbohydrates, active site present. Wow, so obvious, right? Active site present, straight away out. Hey, it's gone. Don't bother about the other 2. Okay, carbohydrates contains CHO. Okay, correct. All right, this one. Formed from 2 different types of molecules. Possible? I can have my fructose and my glucose. So yeah, this is correct. So B and C still there. D, positive result, ethanol emulsion. Wow, don't waste time totally wrong. Okay, so now I just need to focus on B and C. Fats contain carbon, hydrogen only. Okay, good. Formed from many molecules of the same type. Is it always from the same type? Nah, it's not. If you refresh your triglyceride, I can have different types of triglycerides. Okay, I can have different types. But even if you don't know, sure, this one I don't know, this one correct. How? I go to the last one. Proteins. Got nitrogen. Good. Formed from many molecules of the same type. Do I only have one type of amino acid? No, right? I have 20 types. So straight away wrong. So I might not know why B is correct, but I should know C, this one question mark, gone. Therefore, the answer here is B. Here so far. Okay. Question 3. Enzyme reaction. So over here, okay, when it comes to enzyme reaction, it's usually going to be testing you either pH or temperature. So here, factor cut is pH. So they tell me over here, I have a pH of 15 to 25. I incubated here at 15 to 25. So the question to ask yourself now is this. This is human pancreatic amylase. What is the optimal temperature? Human body temperature is about 37. Why am I asking this question? Because you need to make sure, has the enzyme been put in a temperature where it will denature? Okay, so clear cut. Here's not the denature. Course why? Denature means there will be no result, which means there should be a 0 here. So now that I know it's not at beyond optimal, I can ignore that. Then over here, it's quite straightforward. They're asking me which one would show, okay, the rough rate of reaction. A 1 to 20, A got increase what? Makes sense. 20, 40, A increase makes sense what? Because I'm increasing temperature. 30, 30, A no increase, no leh. When I increase temperature, I increase kinetic energy. So I should get more reaction. So C is out. Then D, 40, 120, also increase. So how do I know which of the three answers is the answer? That's where you have to go back to your notes to that one small part which they mentioned for enzymes. Whenever I increase my temperature, what happens? It doubles with every 10 degrees. So some kids will miss this out. That's why I put this as a question here. It will double every 10 degrees. So it means by math, I will just go to the lower temperature. Here is 20. I increase 10 degrees to 25. 40. Correct. Here 40. I should double. It should give me 80. This is beyond 80. So the answer is wrong. Answer here is simply B. Okay? So on that note, you also need to be sharp to realize if the differences between the temperature ranges are 15, 25, 10, 10, 10, 10, it's a hint to you, you must bring in that concept. Increase in 10 degrees per temperature doubles my rate of reaction. Okay, so far? Right. Now, question 4. Which conversion does not take place in the body of a human? This one. Okay, so it's a very straightforward factual question. Let's do by elimination. First thing first, human. Human means not a plant, which means any carbohydrate that I find in plant, like my starch, my cellulose, I can actually remove. So, boom, 2 is gone. Okay, then I go into this. Just before, does not take place in a human body. Does not take place, ma. Okay, straight away, A, B, okay, will be my answer. But I should double check first. Why? In case there's another answer here, okay, which is better. Okay, so amino acids to polypeptides. Of course, that happens. This is how you get your proof. Glycerol and fatty acid into fats. This happens, you all haven't learned yet, but you will learn after digestion. This is how human beings become fatter and older. So fat storage. Then glycogen to glucose. This one you do every single PE lesson. Whenever you run until no energy already, your blood sugar level drops very low. Your body will break your stored glycogen into glucose. Okay, for respiration. So 1, 3, and 4 all can. Glucose cannot happen, will not be changed to starch in a human. So therefore, the answer here will be A. A will be B. Now, if they change the question around, if they say does not take place in a plant, what would the answer be now? Okay. So which does not take place in a plant? I flip it around now. So just to share with you all. Yeah. Okay, Ray Heng, I come to your question. Okay. So if it's a plant, just to share with you, plants will also have proteins. Take note, we have soy protein. Protein, right? So plants also need to grow. Plants also have enzymes. Plants will also make proteins. So this one will happen. Now, plants will have oil, okay? They will have fats, okay? So this does happen. How do you know plants have oils and fats? When you go home, you fry your food, we cook with oil from plants, right? Your sunflower oil, soybean oil. So this will also happen. But can plants ever have glycogen? No. So if I change the question around into which does not take place in a plant, the answer here will be number 4, which is D. Okay, let's go back to question 3 again. Why is A not the answer? Sorry. Okay, so I thought it was important, but I'll go through. So based on the principle that rate of reaction doubles every 10 degrees Celsius. So I must look at my lower temperature first. It's 1 degree, no, at 15 degrees, this is my rate. So if 15 degrees doubles, no, changes to 25, what would double here? 1 would times 2. So it will give me a rate of 2. But over here in the answer, it is 20. So from 1 increasing to 20, that is not doubling. That is increasing by 20 times, which is wrong. Okay, so it's the same reason why D is wrong, because D has increased by 3 times. A has increased by 20 times. By 20 times. B has increased by 2 times. Okay, compared to this value here, 20, 40, and 120. Can? Rehan? I hope that answered your question. Thank you for bringing my attention back to the fact that I didn't go through A. Right. Okay, next question number 5. This one. Okay, testing your ability to look at the different structures and see whether you know how to identify them. So what is the first thing I will do before even touching the question at all is I will write above what does each test for. This reagent, this one will test for reducing sugar. High chance, glucose. Burette solution, test for proteins. Okay. Ethanol, test for fats. So I'm like, oh, testing for all 3. Okay. Then they tell me over here, blue with Benedict's. So blue with Benedict's means what? It's a negative result for my reducing sugar. So no reducing sugar. Purple with protein, positive result, because purple burette give positive. Then my fats, cloudy with ethanol, so I have fats. So which molecules does the sample contain? So now it's my time to learn which one looks like which. So now, over here, okay, like what I mentioned before, if you really don't know which one is which, use the elements first. Over here, I got N. I got an N. I got N. So here must be my protein. Then now I come to this way. Wow, if you really don't know which one is, you really can't remember the exam, right? Okay, look at the ratio. Over here, I got 1, 2, 3, 4, 5, 6. I got 6 carbon. Then I count, I got 12 hydrogen. What am I doing? C, 6, 12, 2, 6. So after you count, A got fixed ratio. This one, okay, I can't even count the number of hydrogens. Why? Because here they tell me it's a hydrocarbon chain. Hydrocarbon chain only found in one thing, lipids. Okay. So I got fixed ratio between these two. This one should be my carbs. This one should be my lipids. Okay. And then over here, I only got protein. I only got lipid. It should be W and Y. Therefore, the answer is simply W and Y. So far. Okay. Now, question 6. I put this question here because I wanted to test you guys. Now, so it's an enzyme reaction rate. Okay. Before I even go to the question, let me do another test with you to see whether you all know. What do I call this particular energy? Anybody? If you can put it in the chat group, it will be good. What do I call this particular energy, which I'll label it as A? What is this bump over here? Then I have B. And later, I will have C. So what are these three different energies which they can test you in the MCQ? All right. So first one, A is my activation energy of the catalyzed reaction. So A is my enzyme catalyzed reaction. Right? What is B then? So B is the EA of the uncatalyzed reaction. So B is just without enzyme. Then the question now is C. What is C? C is the difference. So why am I spending some time to teach you this? Is so that when it comes up in the MCQ exam, the test, and they ask you, maybe this time, they know, we test you so many times already. You all know what is the activation energy of a catalyzed reaction. They don't want to test you this, they test you this too. Wow, then you gabra. So that's why I spend some time to teach you what is the difference of each. C is the difference between the two different activation energies. B is uncatalyzed, A is catalyzed. Okay, then what is Z? Okay, Z will be the energy of the reaction. So let's look at the options over here. Okay, X. Whoa. Right. So straight away, I know that my X has to be uncatalyzed. So X has to be uncatalyzed. Straight away, I can eliminate the first two. Okay. Then, hey, Y here is both catalyzed, both correct. Now let me go to the last one, Z. What is Z called? Okay, Z is your overall energy of the reaction. So the explanation for Z will come in your pure chem. Pure chem will teach you why this is called overall energy change. But I can just share with you now, this is called your delta H, enthalpy change. So sometimes it's below the line, sometimes it's above the line, you end higher. Okay, so pure chemistry will cover this eventually, but that's what we call the overall energy change of a reaction. So therefore, the answer here is simply D. Okay. Now, question 7, right? When it comes to an enzyme graph, I'll give you this very important tip. First thing first, identify the axis. Okay, I'll make big in red. Take note, always identify the axis when it comes to enzyme questions for graph. Why? It's very easy. Enzyme graphs are too easy, but because it's so easy, teachers will always make it tough by changing the axis over here so that the students will have to think a bit. So the saddest story is students assume the axis, then they try and solve it, and they got the wrong axis, and therefore they chose the wrong answer. So always read. So let's say for this one over here, it is the relationship between, okay, temperature and enzyme activity. So I should know, temperature increases, activity goes up. They tell me one important information. Bacteria grows optimally between 80 to 110. So in my head, I do a mental note lah. After 110, what happens? Denature. So if I didn't know it's between temperature and activity, what's the point? They never label the site. Label yourself, lor. Rate of reaction. So this one quite clear. 110 it will denature. At the early part, with increasing KE, my reaction will increase. What graph am I looking for? I can sketch it first. It will go up, reach a peak, then you'll pyong. So where will it pyong and drop? Over here must be after 110. So now let's look at the graph over here. 100 still going strong, cannot be. After 110, 100 here, the ruler starts to go down. This is possible, put a tick. This one peaks and drops way before 110. wrong. Over here, can what? It peaks at 10 and goes down. But why cannot? Let's take a moment to take note. On the left here, this is my rate of reaction. And this line in the graph is touching 0. So it's touching 0 at this part. You are telling the examiner that the bacteria at this temperature range from 0 to, let's say here is 50 degrees. There is 0 reaction. Sorry, 0 enzyme activity. An enzyme only has 0 activity in one scenario, where it's denatured. So D is wrong. Option 4 is wrong because you are telling the examiner, if I choose option, you are telling me from 0 to 50, the enzyme was denatured. But then when I increase the temperature from 50 to 100, wow, the denatured enzyme become back to functional form. Is that possible? No lah. Denaturation is irreversible. That's why D is wrong. So watch out for the axis, watch out for 0. And just to be very clear, in case some of you are asking, okay, I'll go to the first one. So then over here, how come it's touching 0 then? By right, here shouldn't touch 0 lah. So if I zoom in all the way, okay, if I zoom in all the way, your teacher will tell you, no lah, if I draw the graph, it's barely touching. Almost there, almost, but never touching. But because we never zoom in, we cannot see. So by right, this will never hit 0. It will always be above 0. Can, my friends? Okay. Now, question 8. I like that story. So now, for those of you who find difficulty in such questions, got egg white suspension, got enzyme, very stressed. Do this step by step. First part, I'll write down here. Enzyme on the main nutrient present in egg white. What's the main nutrient here? Protein. Now, so my enzyme's job is to digest. Sorry, it is to digest, aka break down. So if I have a protein here, let's say I draw my egg strip like this. If the enzyme is here to break this down, what will happen over time? Okay, over time, it will slowly make the egg lesser until eventually, pew, it's gone. So for this question, you have to understand that if the enzyme is doing its job, if the enzyme can function, my egg white should disappear. So egg white should disappear if the protein is functioning. Then now we have to check what is the environment of this enzyme. This Jenny is found in humans. So in case you don't know, every time in the enzyme question, if they never tell you what is the enzyme, right, just assume it's an enzyme found in an animal or human, which means the optimal temperature is close to our body temperature. Okay, I say again, if they never give you the source of the enzyme, always just assume, you are expected to assume that it is from the human body, or the optimal temperature is close to the human body, which is about 37 degrees. Okay, 35 to 37. Then I see here, 35 degrees water bath. This is good. So temperature will not cause anything to go wrong. Then I look at the different scenarios over here. Okay, enzyme in dilute acid, enzyme in dilute alkali, enzyme in water, dilute acid, dilute alkali. What is the difference in these things over here? First thing first, we don't add in things that we don't see. Only these three got enzymes. This one don't have. So if no enzymes, am I expecting my egg white to be broken down? Okay, by right, I wouldn't. But then I see over here, A, got a bit leh. So here, got a bit. Okay. Then in the water, completely zero. How I know? It is the same as dilute acid. Enzyme in dilute acid also a zero. The one that has the biggest change will be this one. Enzyme in dilute alkali. Wow, a lot. So the enzyme is found in an alkali environment in the digestive system. Okay, and it breaks down protein. Straight away, which are the two locations that break down protein in your digestive system? I know this is not part of these two topics, okay, but some of you would be learning nutrition in humans now, and some of you might have this topic in your WA. That's why I put this in. So protein digestion only got two places. Stomach, small intestines. Stomach is gonna be acidic. Okay, all my acid ones, nothing happened. So it cannot be my stomach. What's the solution gonna be? Small intestine. Okay, so I didn't even bother, okay, looking. But then you see, sure. Now, don't have small intestine here, how to solve? Take note, this was all the evaluation analysis of the enzyme doing its work. Next part here, they're asking you not where the reaction is taking place. They're asking you where was this enzyme obtained from. So what is the source? Okay, and I don't need to get the answers, but I know for a fact we have 23 people here today, right? At least 2 to 3 people would have by accident chosen number 1, liver. This one, okay, can I implore you in your school's notes or whatever notes you used to study, write big on top of the liver topic, okay, under digestion in humans, nutrition in humans. Liver, write big. No enzymes. Oh, my spelling cannot make it. Okay, I get all my students to do this. Why? Sure make the confusion. Liver got no enzymes. What does liver produce for digestion? Bowel. Okay, so it's not enzyme, so straight away liver is out. Right, then next. Mouth has nothing to do with protein digestion. What is digested in my mouth? Carbohydrates, my salivary amylase. So it's straight away out. Then with this stomach and pancreas, if you don't know, make an intelligent guess. The enzyme cannot work in acid. So I know stomach cannot really cancel out. That's why I say cancel out what you know is wrong. The answer is pancreas. Okay, you have your pancreatic enzymes. But even if exam you cannot remember, just by cancelling out what I know is wrong, you will get the mark. Okay? Okay, question 9. This one over here. Sean. Okay, so the question spread over 2 pages. Apologies. Okay. Sean did an experiment. To investigate the effect of temperature on salivary amylase. So what I'm going to show you here is this. Salivary amylase, optimal temperature, 35 degrees Celsius. Right, next thing I know, incubated separated solutions of amylase and starch to 80 degrees. 80 degrees, straight away I know, denatured. Then they transferred these two together. So by the time I transfer together, what's happened to my amylase? Denatured lor. So over here, they show what is the change in the concentration of starch in the boiling tube. So like what I said just now, enzyme questions check the axis. In this thing over here, starch, is this a product or is it a reactant? AKA substrate. Okay? Starch is my substrate. It is my substrate. So when I start any reaction, okay, my substrate should be 100%. Now, when I put, okay, my denatured amylase and starch together, am I going to expect any reaction? No, it is denatured. So no reaction. And if I draw the curve, starch of the equation, starch gives me maltose with my enzyme amylase. If my enzyme here is denatured, what happens? My reaction cannot go. So my 100% of starch will remain at 100% of starch. So which graph here shows me that my starch doesn't change? Now, this one, fracture cut, it remains the same. Most plausible answer. Do concentration of starch decreases, but as it increases, okay, then after it goes down again. Now, this graph would be correct if, okay, they are slowly decreasing, they are doing the experiment at different temperatures. But let's look at the question here now. They heated separated solutions to 80. Means I heat first to 80, then I mix together. All right. Number two, you will get number two's graph only if they did the reaction at 5 degrees. I do at 37 degrees. I do at 80 degrees. Then I will plot this curve. But no, I heated from the start at 80. So I will not get any activity at all. Okay, 0. Now, even if there is a reactivity, okay, even if there's a reaction at 37, shouldn't my concentration of the substrate decrease? But here is very high one. So by you choosing to, you are also a bit confused whether my substrate will go down or go up. Okay, so on all angles, this is wrong. Now, 3. This one, what is 3 telling you? So is there a typo? I got nothing there. No, it's telling you that my line became 0. So when you choose C, you are telling me that after boiling to 80 degrees, all my starch becomes digested. Doesn't happen. Just to be clear, in enzyme questions, when they heat the substrate in the enzyme, nothing usually happens to the substrate. It remains the same. Only your enzyme will be changed and denatured. So 3 is the answer. Okay. The last one, concentration of starch. Okay, so this one would be correct if they slowly increase the temperature from 5 to 80. But I denature already, it wouldn't go down. So most of you will probably choose number 4. Okay, and you will have fallen into the trap. Okay, it was denatured at the start. So at the start, there will be no reaction. The answer will not be 4. All right, the answer will be that one. Okay, this one, quite straightforward. Okay, I won't spend too much time on it, but straight away, my enzyme number 1 is the log. So if my enzyme must be the log, okay, answer only is A. Okay. Okay, and now we come to the questions over here. Okay, structured questions for everything. Now, to be told the topic on biomolecules, there is not that many content in which they can test you one topic very, very deeply. So what would they test you with? Very factual fun facts. Differences or similarities in structure or function. Okay. Or they will test you food test. So how would they test you the food test? Usually it will be this common word. Describe how you can So that's when you say, describe how you can test for a sample. You write in the steps of your food test, which is usually 2 marks. So food test is usually 2 marks. 1 mark for you stating what reagent to put in. So 1 mark is for the steps on reagent adding. The other 1 mark, please take note, is for your conclusion. So for food test, usually they will ask you, I want you to test it on this unknown sample. So if I'm doing the test on the sample, you must tell the marker in the writing, I get this result, what does it mean? For example, I do a starch test. So if the sample turns blue-black, starch is present. If the sample remains yellow-brown, okay, or brown, starch is absent. So that last line must be my concluding statement. Clear? for food test. Okay. So over here, this one is not about food test. It's about similarities and differences in triglycerides and polysaccharides. So if the word polysaccharides throws you off, I cannot think what is it. I share put on top carbohydrates. Okay, so these are the similarity. Not that much, but generally, okay, what can I say? Both contain CHO. What else? This is structure and function, right? Both can provide energy storage. So those are my two similarities. Now, both have the element CHO, okay, B, energy storage. All right. Now, differences. Okay, so what are the differences for this? Now, feature, polysaccharide, triglyceride. Okay, so feature one. Okay, what can I say? Okay, by the way, there are other similarities. Polysaccharide can also be my starch. So under here, it can also be insoluble in water. Clear? Now, so differences, what can I compare? First one, I can compare my C, basic unit. What's the basic unit for polysaccharide? Here, glucose. Here will be my fatty acids. My 3 fatty acids plus glycerol. All right, next feature that I can compare. Okay, what else I can compare besides the basic unit? I can compare the types in the poly form. So I can put for F, I can be number of basic units. Okay, so for my starch, it is only going to be made out of glucose all the way. So just to be clear, disaccharide can be 2 different carbohydrates. But for polysaccharide, so 2 different monosaccharides. But for polysaccharide, like your glycogen and starch, it is fully only one type. Here. This one can be many types. Okay, so even if you don't get the fatty acid part, here got glycerol, here got fatty acid. Straight away already 2 types. Right? Now don't worry too much about the answers. Okay, as mentioned, we will share the answer version online with you after the lesson. Okay, so to answer Marilyn, yes, just to be very clear, denaturation is irreversible. I say again, it's irreversible. So I can just give you a very simple real life situation. I have raw egg. Raw egg, the protein, the egg white is protein. When I cook my protein, I cook my egg white. This becomes white. If I put the cooked egg white in the fridge, will it become back to being raw? No, right? I just get a cold cooked egg. So same as your meat, same as any protein source in the world. Once you denature it, it cannot be reversed. And enzymes are proteins. So therefore, when I denature the enzyme, it can never be reversed back into its functional form. Okay, thanks for asking the question, Marilyn. It's a very valid question. Okay, I think many other people probably also had that question in mind. Thank you so much. Now, question 12, lipase. Okay, so lipase on milk was conducted. Did an experiment adding equal amounts of milk and sodium carbonate solution. So once again, like I mentioned, because generally most of you for WA2, okay, who probably might have nutrition in humans, I added some questions where I got biomolecules, enzymes, and nutrition in humans. So why did they put the sodium bicarb solution? Okay, in case you didn't realize, the reason why they put the sodium carbonate solution is because, okay, it's because this makes it slightly alkaline. Okay, makes slightly alkaline if I am not wrong. So over here, okay, and why does it need to be slightly alkaline? Think about it. Where do I find lipases in the human body? For digestion, this is usually in your duodenum. external, which is pH8. So if I don't put this solution there, my lipase cannot really work. Okay. Now, so tell you over here, lipase was added to tube 1 and tube 3. While what lipase added to, once I see board say, wow, the nature means zero reaction. Then over here, this question maybe was also shown before. They probably have some indicator. Okay, this indicator is a pH indicator. So pink in alkali, colors for this. So I've learned through experience, kids when it's in the word form, sentence form, they cannot see it. So what I'd like to encourage you to do is this. Take out your pen, write down here. Okay. B, I will just draw a pH scale like this. Okay, a pH scale. I'll draw pH 7. Then I'll draw pH 8.3. Alright. So once I know pH 3 is here, colorless when it falls below 8.3, I will put straight away here colorless. So this part I know from pH 1 to 8.3 colorless. Then it will turn pink, okay, in alkaline solutions above pH 10. So here I will draw one line 10 and I'll make pink. So what to make it this form? Wow, it's so easy to look at and understand. You get less confused. So pH 14 over here. Down. Okay. Then over here, it gives you the contents of sodium bicarb, lipase. So the question now is this. What in the world will cause a pH change? pH change means I need acid or alkali. This is the question on lipids. What link is lipids, okay, to acid or alkali? Answer is your fatty acids. Then once you know it's fatty acids, straight away I can draw the relationship by the side, which is what? If I have digestion, lipids gives me fatty acids. If at the start, it tell me over here, okay, I put this sodium bicarb, this sodium carbonate solution. It means at the start here, I'll put below, should be alkali. And over here, because after digestion, I have fatty acids and glycerol. What happens now? This becomes acidic. So if I know it's alkali, what color will it be? It will be pink. If it's acidic, what will it be? Based on the question above, this would give me a nice colorless solution. So once you draw the equation, now it becomes more manageable for you. Because I've basically broken down the whole description into just one equation with color. Right? Then they tell me the time required for the contents to turn white after addition of lipase was measured. Predict the order in which this will happen. So prediction, quite straightforward. Prediction doesn't mean explanation. So no explanation. So which one will be last? Why did I go with last? Because I have one fella here which has white lipase. So will this ever change color? Never. It will never change color. So if they tell you, read the order in which it turned white, can my tube 2 be part of the order? No. Tube 2 will remain the same. Okay, it will remain same. So what is the same here? The same here is pink. Why? Because by default, I'm alkaline, I'm pink. Then which will turn first? Now let's look what is the difference between tube 1 and tube 3. 7 cm cube, 7 cm cube, 1 cm cube, 5 cm cube. Now, then they give me information here. Bulk salts added into 2 and 3 only. So they're very cheeky. Right? So the bulk salts will be here. So with bow sorts, this will be most optimal. So it should be 3, then 1, then full stop. 2 remains the same. And that is the answer over here. Okay? So your tube 3 first, then tube 1. Right? Okay, so sorry, because of the format we use, it will keep doing the same question. So predict your answer. So explain your question in A, right? Where do I get the 4 marks from? So it would really be just explaining this description over here, which is first part. What happens? Okay. I'll always mention the first thing first. My color change is based on digestion. So first idea I will mark is lipids digested to give me fatty acids plus glycerol due to my lipase. Okay. Then now that I have fatty acids here, fatty acids will cause pH to decrease, more acidic. When pH decreases, what happens to color change? Pink to colorless. Okay, it will cause it to become colorless. So that is the general thing I'll say first because it applies to all tubes. This itself won't give you 4 marks. Next part is this. My prediction in A is why tube 3 first, then tube 1. So next part, I'll explain why tube 3 first. Because for tube 3 has bow. What's so good about bow? Emulsification to increase the surface area for lipase activity, and therefore time is shorter. Then there's tube 3. Then we talk about tube 1. When you talk about tube 1 and tube 3, they are together. So tube 3 got bow, tube 1 don't have. That's why tube 3 changes faster. Then the 5th point will be what? Hitting here, how come my tube 2 remain the same? Tube 2 denatured lipase. So this is the rough analysis of the points to write for the 4 marks over here. Okay, this is the rough point. So the order you can change. You can say tube 2 first, then tube 3, tube 1. So can. But as long as you put the general principle, point 1, 2, and 3, what happens? Okay, what's the science behind it? Then 4 and 5, you explain what the tube should be fine. Okay. Right. Now, then this part over here, okay, like wondering why got so many lines. Okay, I'm not crazy, but if not, the next question will eat into this. So I put this there so that it's very nice. But key idea is, what is it necessary to use sodium carbonate? Which is the beauty about my question analysis skill. So because I analyzed so early at the start that this thing has to happen in the duodenum, and when they ask me, why must I put sodium carbonate? Because this reaction is happening in the small intestine. Why? Because my lipase has an optimal pH, which is alkali. This thing is alkali. Okay, that's all. So, mention clearly, my lipase needs an optimum pH, which is alkali. And sodium carbonate is an alkali. So the common mistake students have is they won't make this last thing. They just say, oh, lipase needs to be alkali. Oh, good. So why? It needs to be alkali. What's the link with sodium carbonate? Okay. Okay. So over here, okay, this question goes further by enzymes, right? Produced by bacteria used to convert plants, such as corn, into biofuels. We can use biofuels instead of diesel or petrol. In short, it's a different kind of energy source. Then this graph is very interesting because there are 2 variables here. One by color, one by pH. So clearly we can see. Okay, now this one you must be able to tell the different shades in gray. So even if you cannot help yourself, lah, 1, 2, 3, 4, 5, which means 1, 2, 3, 4, 5. And you can always tell which temperature seems to be at the peak. It will be my temperature 60. So 60 would be my optimal temperature. Right? And you can see at 70 is always very much lower than 50. So 70 is where it starts to denature. Okay, so just to be clear, 60 might not be the optimal temperature, but it's close to being optimal. Right? Now, then over here, which pH would be the best? pH 7.5. Why? Because out of all, it produces the most. So this question is a very tricky question because they ask you with reference to figure 2, describe the activity of the enzyme and explain why this information is useful to produce biofilm. So first part, what do I mention? Activity means what? What is the optimal pH? What is the best temperature? So write down pH. Okay. Now, which temperature is the enzyme active from? Take note, here is optimal, it's optimal. But the question is asking you activity. So technically it's what? As my pH increases from 6 to 8, there's activity. All right. But optimal is 7.5. Same thing for temperature. There's activity from 30 to 70 degrees. But which is optimal? Optimal temperature is 60 degrees. Right? Then, how do I answer this part over here? Why is it useful to manufacturers? If I want to make the most biofuel in the fastest time, I will use the most optimal environment, and that is the answer. So the people making biofuels will want to use the information to make the best conditions for manufacturing biofuels. That's all. Okay, to save money and maximize the cost. Okay, cost effectiveness. Right. Then over here, biofuels can be burned in vehicle engines, suggests how biofuels can result in pollution and cause environmental change. Okay, so I left this here because the suggest question. Suggest means you haven't learned your syllabus, but this one, I think you can answer. I burn biofuels, it gives me CO2, which is a greenhouse gas. So what I put this picture here, I wanted to show you all this. Don't be so afraid of suggest questions. Suggest questions are usually questions that your school never put in syllabus because it's not in your learning objective. But you have learned somewhere in your life knowledge that can help you answer this. Okay? So this one, burning CO2 gives me burning biofuels. Gives me your CO2. That is 1 mark. Second mark, CO2 is a greenhouse gas, which leads to climate change. And that's the rough thinking process, and you will definitely get 2 marks. Okay? Okay? Okay. Now, last one over here. Okay, so this one over here is a graph question. Okay. Some key on the neck before you draw the graph. So this is how I teach my students to draw graph. And in case you don't know, how do teachers mark you for graph? All right. First thing first, your first mark will be your intervals. So what do I mean by intervals? When you draw your graph, always make sure you have that hey, the line like this, right? Okay, I can't draw freehand straight line, but extend your line beyond the graphic board. First part, don't ever draw inside, draw outside. Then, intervals must be regular. So that means every single interval over here is 10 squares. So if you are someone who somehow likes to draw your graph, And your interval, halfway is like, here I put 5 squares, 5, 5. Here I put 10 squares. Straight away, you get 0 marks for the intervals. Clear? Next, part of that mark, you have to label everything. So most kids, okay, I know some of your school will teach you, I just label 1, 0 here. Bad habit lah. Can I just suggest, put the 0 at both ends? Why? I teach junior college, JC, A-levels. So if you want to take A-level bio eventually, you will only get correct if you put like this. You put a 0 in the middle, Cambridge will mark you wrong. So since you're going to learn it from scratch, just start now and have a good habit. Okay, so your intervals. Second mark will be scale. Okay, they give the axis. Yeah, okay. So I'm not drawing based on this right now. I'm giving. Oh, thanks, Diana. Okay, so I'm just giving generic stuff to tell you. Okay, because I'm not drawing this thing now. I'm just nagging generic stuff. Next part, okay. Now they give you the scale, you follow the scale lah. Okay. Next part over here is scale to cover graph paper. So teacher will teach you about half or 2/3. So your graph cannot be one small part here, right? Okay, 0 marks. How they check? They will really measure your squares. Okay. Third mark, your plotting. Okay, whether you plot the correct value, that one I cannot help you lah. Fourth mark is your line. So I'll do a very quick summary of the line. Okay. If you see your points up, down, and no matter how you do it, you cannot link all them together. It looks like a heartbeat. Okay. It looks like a heartbeat like that. They are giving you a hint. It's not meant to join together. So when this thing happens, it's your line of best fit. Straight away join your line of best fit. Okay. Above and below, about same number of points. Now, if you see the points, and the points you can tell, forming quite a nice curve, it is then going to be a curve. Okay, so when teachers create a graph question, they have to draw first, then get the values. That's why they know what shape they're going to get. Last one, very rare. If you plot all your points like this, like this, like this, and you put your ruler there, and it can really form a straight line, then it's meant to be a straight line. So these are the only 3 kinds of graphs you are generally going to draw. Usually, it will be your line of best fit, usually lah. But for enzymes, okay, enzymes will never be a line of best fit. Okay, it will be a curve or best fit or a curve itself. Why? Enzyme questions are always curve. Slow at the start, faster at the back. Okay, so last question I cannot go through with you. Okay, but I put the extra question there just for extra practice for you to practice drawing a graph. All right, I'm mindful of time, so I want to close the session. Okay, so to close, generally, right, if you enjoyed my session, okay, and you found it good, okay, you are not alone. There are other people who have found it pretty useful lah. Okay, so Zena at the bottom, who also in this video, joined me previously for lessons. Okay, so generally, if you think I'm good, you're not alone, right? But if you think I'm not for you, it's also okay. End of the day, this is just a free session to help you. And I hope I've helped you. All right, now, next part. Yeah, I'm going to skip all of this. I will share with you my current class timing. So I only teach one Sec 3 class on Sunday. Okay, not to scare people, okay, but actually I only have 1 to 2 seats left. It's currently about 10 students. Okay, the classroom can only fit maybe 12 or 13. So if you enjoyed my session today, and if you feel you want to join me for this journey on Sec 3 Bio, I'm available for lessons on Coven, Sunday at 10 AM. But if you want to join for Bio, okay, but you don't want Sunday because you're not free, there's another lesson happening at Sec 3, okay, at Tampines, Tuesday, 4:30 to 6:30, under my equally, okay, great bio teacher, Mr. Jason Fang, okay, who wrote our textbook. Okay, so if not, okay, if you want to know more about class timings and other stuff, you can just scan the QR code here. But other than that, I've come to the end of the session. Okay, anyone who has any small questions which I can answer in 5 minutes, feel free to leave it in the chat. I'll answer you. If not, thanks for joining me today. Have a great rest of the weekend and all the best to your WA2. Okay, bye-bye.